So in time zones, everybody in a certain region of the Earth will have the same time. And then when you move by 1 hour to the next one. And since it takes 24 hours to go around, how many time zones on the Earth? Well, there's 24. And these time zones became known as standard time. Before that, and before the trains, every little town would have their own time. And everybody would set their clock to that time. And if you look at a lot of small towns in the early 1800s, on the center of the town they would have their city hall, they'd have a clock on it. And everybody in the town would set their clock to the same as the time in that city hall. But if you went from one town to the next, it wouldn't match each other. Okay, so that's where time zones came in. And now what we want to know is, remember this is the North Pole sticking out of the Earth, so we're looking around the equator here. And there's 360 degrees of longitude all the way along. Remember, longitude is how far east or west you are. And so how many degrees of longitude is there in each time zone? Well, it's very easy to figure out because we know there's 360 degrees in a circle, and there's 24 time zones. And if you divide that, you get 15 degrees per time zone. So each of these time zones is 15 degrees across. Okay? What was the longitude of Commerce, Texas? Of Commerce, you remember, was about 95 degrees west. That means we're 95 degrees west of the prime meridian, or essentially west of England. Okay? How many time zones is that? Well, if we make this easier, let's just round this to 90. 90 divided by 15 is just 6. So we are 6 time zones, or 6 hours from what they call GMT, which is Greenwich Mean Time, which is the time zone of the prime meridian, which essentially sets time for the whole world. Because everybody synchronizes to Greenwich Mean Time, and then you figure out whether you're how many hours ahead or behind you are from that point. Now there are some exceptions. Like India, parts of India are actually like 5.5 hours off instead of 6. Part of that is because the time zone kind of split right through the middle of India, and so it didn't match well to either one. Part of it was that India was upset about British rule, because you know British ruled them for so long, and so they kind of said, well, we're going to be a half hour off. So theirs is kind of messed up. But most everywhere in the world is a certain number of hours from Greenwich Mean Time. Now, we're 6 hours off, but we're not 6 hours right now in the summer. In the summer, we're actually 5 hours off. Why are we 5 hours off? Well, we have something called daylight savings time. All right. Daylight savings time just says that, and it started about the Industrial Revolution, when people started working in factories and they had to go to work at a certain time and come home at a certain time, and started working from your 8 to 5 jobs, your 9 to 5 jobs. And they said, well, we know that because the sun changes its altitude, its declination, which changes its altitude in the summer, we get longer days in the summer, shorter days in the winter. It would be nice, it'd be more advantageous if we had more light in the evening than we do in the morning. Because if you don't switch, then the sun will be rising around the summer solstice. It's at like 4 in the morning, but nobody wants to get up at 4 in the morning. We would rather have time after we get off work. So you get off work at 5 o'clock, you want to go outside, you want to have a barbecue, you want to hang out in your backyard. You'd rather have more daylight. And so daylight saving time is just saying, oh, well, the Earth changes throughout the year, so let's switch our clocks to actually match the daylight and put the daylight when we want it the most. And so what we do, and now it starts in March and ends in November. I think it's the second Sunday in March, and it ends the first Sunday in November. It used to be, it would start first Sunday in April and end in October. But just a few years ago, the government decided that we were going to extend daylight savings time. The reason for that is when we're on daylight savings time, which is in the summer, we actually save a little bit of energy because you come home and it's light out, you don't turn on as many lights in your house, and so it saves like 1% of the energy. Well, 1% is a big deal when you have 400 million people using electricity. So they extended daylight savings time to save energy. It's actually worked out better for university students too, because now it almost always starts in March during our spring break, and so the students don't have to worry about coming to class right after it's changed. They have a whole week to adjust. The one in November isn't as big a deal because in the one in November you actually get the extra hour, you lose the hour in March. So what happens is, in March when we switch, we're going to make our clock spring ahead, or we're going to have one 23-hour day. And so you lose an hour. That's why people have a hard time. They're like, oh, you lose an hour, and they messes up their sleep, and everybody complains, oh, why is this so hard on me? Well, it's just 1 hour, 1 day of the year. Then, in November, we have a day where we actually have 25 hours. We add an extra hour, that one, and we do it in the middle of the night. Okay? They usually do it at 2 in the morning. Why do they do it at 2 in the morning? Because most bars close at 2 in the morning. And so the switch is right after the bars close, so you don't have that extra hour. That's why they do it that way. So currently, when you're in the summer and we're in Texas, we are under what we call Central Daylight Time. In the winter, we're under what we call Central Standard Time. And if you go east of us, you get to Eastern Standard Time in the winter or Eastern Daylight Time in the summer. Now, there are still some states that don't adjust for daylight savings time. Arizona does not adjust, and Hawaii does not adjust. Hawaii doesn't adjust because it's close to the equator, and as you get closer to the equator, the change of daylight hours is less significant. And so all the countries around the equator, close to the equator, they don't do daylight savings time. But any of them that are further north or further south will do daylight savings time. All of North America does it, Europe all does it, Asian countries do it as well. So it's done most of the world. They switch their clocks. But it can be changed for local circumstances. Why Arizona doesn't do it, I don't know. It's Arizona. They always want to do something different. All right, so let's talk about time with respect to your position on the earth. So for example, here we have the sun. And I always draw the sun on the right side of your paper and then put the earth right here, because then it'll be consistent and it's easier to deal with. Remember, the North Pole is sticking out, so we're looking down on the North Pole of the earth. When Herb is over here, we already talked about the sun is over his head, or the sun's on the meridian. And so we call this local noon. Now the earth is spinning counterclockwise, and this half of the earth over here is in darkness. Because the sun is always lighting up exactly half of the earth. Now, how much or what part of the earth gets that half is dependent upon the seasons and the tilt of the earth and which way the North Pole is pointing, whether it's towards or away, which we talked about with the seasons. But if we get up here, so the earth is now rotated, and it's rotated 6 hours because it's 1/4 of the way around. This is 6 p.m. Okay? But I'm going to draw the horizon here of Herb. Meaning Herb's standing on the earth. Remember, north is this way, so we're kind of looking at it from the North Pole because the north is sticking up. East is the direction that the earth rotates. So we talked about this before, the earth always spins to the east. So this direction is east, this direction is west. So where's the sun? At 6 p.m., well, the sun is in the west, which means the sun is setting. So this would be sunset. The sun is in the west. Okay, when Herb is down here, this is midnight. And if I draw my horizon, Earth is spinning to the east, remember, counterclockwise, so this direction is east, this direction is west. At this time, right, you can't see the sun, but the Earth is still continuing to rotate around, and then I'll put Herb down here. This is Herb's horizon. Right here, this is 6 a.m. But which way is east? Well, remember we're rotating, so down here, this direction is east, this direction is west. So to the east is this way. Sun is over here to the east, 6 a.m. And so the sun is rising because it's in the eastern part of the sky. And then for completeness here, we will also do it at noon. So notice how, as the Earth rotates through one day, east, compared to the stars in the sky, changes directions. So does west, so does what's overhead. That's why the whole sky, all the stars and everything seem to rotate around us. It's because we're spinning around them. And we're spinning to the east, so everything seems to rise in the eastern sky. All right. So, keep that in mind. We can do that to figure out our longitude, and this is how ship's captains used to do it in the back of the day when they'd sail to their island and say, what's the longitude of it? You get the latitude by measuring the altitude of the sun. We already talked about that. But to get the longitude, you have to compare time. So, for example, this is a problem.